This is the 9th video in my series on three-phase power transformers. In this video, I'll be looking at Y delta connections. To be more specific, the current flow in Y delta connected transformers. In previous videos, we saw the phase relationship between the voltages and currents in this type of transformer. In this video, we will be looking at phase relationships as well as the magnitude. You can find out more on this subject in my course entitled Electrical Three-Phase Power Transformer Fundamentals. You can access this and my other courses on my Stan Store at this web address. Looking closer at this triangle, which is made up of the red phase current and the minus blue phase current in the I line of the red phase secondary. We'll call them R minus B and I line. It is an isosceles triangle, and we've seen this exercise before. The triangle is made up of two 60, 30, 90 triangles, which means the length of the arrow I line R secondary, or the magnitude I line R secondary, is made up of the ratios of the red magnitude root 3 over 2 plus the minus B magnitude root 3 all over 2. And because we're dealing with just magnitudes, we can say that the red magnitude is equal to the minus blue magnitude. So we can replace the minus B magnitude in our equation with the R magnitude. Rewriting the equation, we get root 3 times 2 times the R magnitude all over 2. And the 2's in the numerator and denominator cancel out, leaving us with I line R secondary is equal to root 3 times R magnitude. Now I'm just going to switch back a little bit before progressing, and I'm going to recall the voltages of this transformer. We did this in a couple of slides before. The turns ratio of the transformer is given by the voltages of the red phase magnitude, the voltage across the coil or the windings of the red phase over the voltage drop across the windings of the red to white secondary terminals, because the red to white is connected delta. So the turns ratio, when we discovered this before, is given by the magnitude R all over the magnitude RW. And the currents then, if you look at our diagram, the currents in the secondary windings over the currents in the primary windings, the magnitudes, also form the turns ratio of the transformer. And just to recall the theory, I'm going to look back at the slide that discovered this, that the turns ratio can be described in either the voltages or the currents, but they are the inverse of each other. So going back to our equations and looking at the current formula that we just developed, we can rewrite we can replace the uppercase R in the primary, because all of the current flowing in the I line primary flows through the windings of the red phase transformer. So I'm going to replace the capital R with the magnitude I line R primed, and rewriting the equation so that I have the lowercase r magnitude on the left-hand side of that equation because now I want to go across to the other side of this slide and replace the lowercase r magnitude in the last formula that we developed. And I'm going to replace that with a I line r primed, which gives us the relationship between the line current in the secondary on the red phase and the line current in the primary on the red phase. And I'm going to just do something to get rid of the two terms, root 3 times a, just to make it a little bit more concise. I'm going to say let a primed equal a times the root 3. And I can rewrite that equation now, and instead of just looking at the red phase, because we could analyze each one of the red, white, and blue phases and come up with the same thing. So we can say that the magnitude of the secondary line current is equal to A primed times I line primary. And these are magnitudes. But we also, in the previous slide, discovered the phase angle or the phase shift between the primary and secondary. So I can rewrite this equation, placing in the phase shift, and I can drop the magnitude signs and say these are the actual phasor relationships now, where I line secondary current is equal to A prime times I line primary current minus 30 degrees. This video is part of my Electrical Technical Information series. In this series, I'll be covering essential topics to help you understand electrical systems. Be sure and stay tuned, as I will also from time to time be reviewing electrical products that, in my opinion, are worthy of paying attention to. Some of those products include 𝐃𝐈𝐒𝐂𝐋𝐀𝐈𝐌𝐄𝐑 big and small standby generators. This is the best time to try out any of 𝐃𝐈𝐒𝐂𝐋𝐀𝐈𝐌𝐄𝐑 because they are having a huge sale starting April 4th and lasting until April 21st. Here are just a few of their products, starting with the 𝐃𝐈𝐒𝐂 Delta Pro and Delta Pro Ultra and the Delta 2 Max, including the River line of smaller standby generators, the Delta 2, the Wave 2, the Glacier, and the River 2 Pro. The River Pro, the River 2 Max, and the River 2. And a range of portable solar panels, including a 400-watt portable solar panel and a 200-watt bifacial, and the Glacier. And finally, a unique product, the Wave 2, which is a portable air conditioner / heater that fits anywhere. To obtain more information on this subject, simply fill out the information requested when you go to this website. Before I end this video, I want to repeat the connection to obtain my free copy of the Ultimate Guide to Residential Standby Generators and receive access to the major April sales on many of the 𝐃𝐈𝐒𝐂 products. Also, here's the connections to obtain a free copy of my 50-page electrical power crib sheets. And finally, here's the link to all of my electrical courses, which are located in my stand store.